Hi, this is Shubhandev, and here in front of you all is a simple linear regression task provided by the Sparks Foundation. The technical stack we'll be here using is scikit-learn, NumPy, Pandas, and Matplotlib. The step one involves the reading the data from the source. This involves the import of basic libraries such as NumPy, Pandas, and Matplotlib, as we have discussed earlier. Second, the followed by the import of dataset using the Pandas library. As you can see here, the data is imported successfully. Then we'll be seeing the type of data present in the dataset using the data.head part and data.tel. And data.tel gives the last element, the number of the last element here. Then data.isNull.sum. Here we'll be seeing if there is any null value present in the dataset, it will be giving in the form of sum if there is any. Then the data.describe will be giving the actual count of the dataset, and here in front of you all is the parameters there. The describe part gives. Second step is involves the input data visualization. Here, what we'll be saying is the type of graph we have got input, and by the graph only we can visualize that this is a linear regression problem, and the algorithm to be used is the linear regression. Okay, then the third step involves the pre-processing part. Here we'll be dividing the dataset into two parts, x and y, and seeing the which is the output and which is the what are the attributes to be taken for the training and testing. Then model training involves. Then here we'll be dividing the test size as 70 30, 70 for the training and 30 for the test size. The random state here we have taken is 0. You can put any. And this test size also determines the accuracy of the model. Sometimes you can change and you can see the changes. And as you have said by the graph here, that this is a simple linear regression problem. Like with the graph only you can see here, we can analyze that. So here we have imported the linear regression using the sklearn linear model. Then the plotting the line of regression. After training the model, we'll be using the best fit line in order to confirm whether this algorithm fits or not. So here we can easily see this is the best fit line, and all the points, all the prediction, all this revolves around this best fit line. Okay, then making predictions. After that, this is the very foremost thing. Here we'll be predicting the test values, x test values actually, then comparing the actual result to the predicted model result. Okay, here this is what is the actual value in the data set versus the predicted what the machine has predicted. Here you can see that there is not very much gap between the actual and the predicted values. That means the machine has predicted correctly whatever the data is being given to it. And then if we put our own data, how the machine reacts. Suppose we have put the data is 9.25 hours, and then the predicted score is 92.91, means the machine easily detects accuracy up to 92.91% after the training of the model and after the input we have given by our own. Then evaluating the model, and here we'll be evaluating on the four main parameters such as the mean absolute error, mean squared error, then the root mean squared error, and the R2 values. Here we can see the R2 value is very less, 0.9568. That means the model has performed very well, and this is quite an impressive score that this R2 the model is provided. Then the training score and the test score is here. After the training of the model with the help of the dataset, the 70%, what I said is 94%, and with the 30%, 70/30, then that is 0.95 the test score, the rest 30%. And here we can see the actual versus the predicted graph. There is no such variation seen. That means the machine is performed well by giving this data set. Thank you.